Bro, I hate how easy it is. Like, what the fuck? Excuse me. It's literally Go. Look at that. It's literally Go. Here I just accept connections and just do Go client and I pass it there. And then in the client is just like, who needs Go? Like, it works and it's convenient and shit. What the fuck? It's a almost 10 years old library, think about it. And it hasn't been updated much. It's basically the development has stalled. And it works just like Go. Like, what the fuck? Alright, so let's do another library review, shall we? I've got this interesting library, which is called libmeal, and allegedly, it is a library that introduces Go-style concurrency to C. So, they have a bunch of examples, and yeah, that looks like Go. Choose. Wait, how the fuck did they implement that? Is that like based on macros or something like that? So yeah, let's take a look at that. I know nothing about this library, right? So somebody posted this library in the Discord, in our Discord server some time ago, and I just put it in to-do list. So this is the only thing I know about this library, whatever is on the front page. I haven't looked into this library before the stream, right? So because I want it to be like a raw reaction. I'm a library reaction streamer, right? So I want it to be a genuine reaction to this library. So let's fucking go. Let's download this shit. Well, I mean, to be fair, 2017 was probably the last good year. It's been a downhill since then. That's how you know the library is probably good, right? So because they realized that 2017 was peak. And there's no point in doing anything after that. It's not gonna get better than that, so they just stop. Honestly, pro move. I fucking respect that. So let's download this thing. So let's go ahead and just like see what we have in here. wget, and I'm gonna just copy paste this stuff in here. I should have probably created a separate folder for libmeal. Right, so I'm gonna put that stuff in here and unboxing experience. Let's do the unboxing experience. There's something sus about 573. Oh, it's a... Are you fucking serious, motherfucker? You really served me HTML by such link? So I really have to download it through a fucking... go through... Alright, let's do development, I suppose. Oh, there is a... Okay. Sus. Okay. 4 years ago. I mean, it's actually 4 years ago was not 2017, that's for sure. So it's kind of semi-active. Is there any releases? So there are no any releases yet. There are some release tags. But honestly, fuck all of that scheisse. Let's actually, you know, grab the latest version, right? Grab the latest version, maybe with the latest fixes and stuff like that. So it is implemented primarily in C, 91% C, a little bit of a C++, but I'm pretty sure it's entirely in C, right? So because GitHub is dumb. Because it's owned by Microsoft, right? So they couldn't distinguish C and C++. And it's actually on par with Microsoft brand. They don't even have a C compiler. MSVC is a purely C++. They literally don't fucking understand the difference between C and C++, like at all. It's just like, C/C++, that's literally Microsoft when it comes to developing like C and C++ compilers, right? So I'm not surprised that they think that there's a little bit of a C++ in this library. 10 years ago, holy fucking shit. Anyway, let's fucking clone that. 1,000 commits. Maybe we're not gonna do a full deep throat clone. Let's do a shallow clone, right? So let's do a shallow clone. We're gonna do clone, and we're gonna set the depth to 1, right, and hope for the best. Let's fucking hope for the best. Okay, so that was all right. That was all right. And let's actually remove this garbage. What do we have in here? So we have autogen, but we also have CMake. Look at that, chat. ePol Incorporated. I have no idea what the fuck is that. So, well, usually the files with ink are template files, if you know what I mean. So essentially, ink files, they're like include files, but I don't really know what ink stands for. But usually this is the files that are used by the build system to then, you know, generate some other files, right? So they have some parameters and stuff like that. So they're substituted by scripts and everything. Oh, I think it's usually in, not ink. Okay, forget everything I said. So let's actually build this entire thing. So I'm gonna create a build folder, right? Because this is how we use CMake. I'm a professional CMake developer. I know what I'm doing. Then you do CMake ... and it will just configure this entire thing. Deprecation warning, so that's the usual for CMake. And that wasn't that hard. You know, when CMake outputs only how many lines? Only 15 lines, you start to question, do you really need CMake, my guy? Or are you just like doing that because of the reflexes, or I don't know. Like, look at that. Do you really need CMake? Like, you're introducing problems for no actual good reason. It's just like, are you sure? But anyway, we're not questioning that. We're not questioning that. So let's actually build this entire thing with 16 threads. This motherfucker is built. Why am I acting like it's my achievement, right? It's a laptop's achievement. So it did some things, but honestly, I think it would be better to actually install it somewhere. The usual trick I like to do is to configure this entire thing with CMake install prefix, right? And install prefix is basically the folder where it's all going to be installed. Usually I like to install additional stuff into home opt libmil. Like this, right? So this is basically where I install all of the open source stuff. I don't like to install it system-wide, right? So especially when I'm experimenting, so I just install it for the current user, right? So this is going to be the prefix, right? So then I'm going to rebuild it one more time with the 16 threads. Okay, prefix didn't affect any of the source code, but now if I do make install, right, if I do make install, it will install all of that into the opt home folder and stuff like that. So that's basically the final distribution you're supposed to have. What's funny is that it also have executables, right? So it has mil-s and some other things, but it didn't really install them in a final installation, right? Which is, okay, so this is a library, but it's also a library that has an executable. So what are these executables? What are these executables? Does anybody fucking know? Just a second. So I'm gonna do find type name. Let's actually just find all of the executables. Executable. Right. Mil. Oh, maybe it's just the name of a target, but majority of them are just tests. And the main thing in here is just a library. Okay, fair enough. Fair fucking enough. So this is what we got. So we got include, right, which is just one header file. And we get the library, right? So, and we have a static library and we have a dynamic library. And we also have some CMake modules that help you to find libmil. So far, so good. So far, so good, right? So if the this link worked and it gave me this installation, I would have said based library, but something broke, right? So it's kind of interesting. So the library seems to be promising, right? So it seems to be very simple. But this website itself is kind of neglected, right? So it's kind of neglected, which is understandable, right? So the author probably has their own lives, their own job, and this is sort of like maybe their pet project, maybe a recreational programming project. So we're not going to be judging it too harsh, right? So because it feels like it's somebody's pet recreational project, and I really respect that. As a fellow recreational programmer, I fully respect that. So let's see what we have in include headers. What do we have in here? Yeah, that's SQL. It doesn't support. Honestly, okay, look. This is based. This is literally based. Not GNU-C, not Clang. Go fuck yourself. MSVC, get the fuck out of here already, bro. That's already star. Like, I only opened include file and I already see based shit. I fully fucking support that. That's an insta star for me. So what else do we have here? Please don't take me too seriously. I'm just trying to be entertaining, okay? Okay, so I also use MSVC from time to time. I mean, life is more complicated than memes, okay? Life is more complicated. Coroutines, right? So it has these coroutines. Honestly, like, I don't really know what is coroutines. Can anybody explain to me what the fuck is coroutines? Because I keep hearing that word over and over again, and nobody can like properly explain them to me. What's the difference between coroutines and goroutines? Coroutine is nuts. Yeah, that's the most insightful information I got about coroutines so far, honestly, right? So, a routine that is cooperative. Coroutines are computer programs with components that allow execution to be suspended and resumed. Can you think about futures as coroutines in some sense? Because we were developing this library, basically futures for C3, so C3 foot. I'm gonna put it in here. Right, and futures are just basically classic futures, but one of the things that they do, you can actually suspend them until some sort of an event happens. So wait, yeah, okay. So coroutines is things that yields and generator functions like in Python. Okay, so that's what is called coroutines. So when you do yield and, okay. So that means I know what it is, right? I just didn't know that it's called like that. Pretty cool. So now we know. It's kind of cool that they managed to implement it in C. I wonder how you implement that in C, actually. So you probably need to save the content. We have content. As I'm thinking about how you implement that, I literally encounter the code that is responsible for that. So there's some sort of a way to sort of take a snapshot of the current context and maybe recover the current context or something like that. Stacks, okay. So we are talking about stacks. I suppose it's a call stack of some sort. It's also using the AVX instruction. All right. So we're getting deep. We're getting really fucking... I thought it's gonna be like on the level of C, but it's a probably very specific feature that requires you to go underneath C, which implies that you won't be able to run it easily on, for example, ARM, right? So because it's x86-64, right? So it's a custom implementation of set jump, right? So kind of interesting. So set jump is like long jump thingy, right? C set jump. Let me see. So fuck you, Microsoft. I'm not opening your website. Fuck you. Right. So there's a mechanism in C and C++ that allows you to sort of like save an environment, right? So you do set jump, all right, and you save it into the environment, and then you can perform a long jump, right? I think long jump performs the jump and stuff like that. And the way it works, my hypothesis is that it literally saves the state of the registers, right, in that buffer where you do set jump, and then it recovers them. And honestly, I think this is literally what this function does. It literally takes all of the necessary registers in here and just saves them somewhere in the memory where our DX is pointing, I suppose, right? And yeah, so that's literally what's going on here. Just save that. I wonder why they implemented it themselves, right? So because if anything, it just feels like it's limiting the amount of platforms it can work on. Maybe there is several implementation of these things, right? So yeah, maybe there are some several implementations and stuff like that, so that's pretty cool. MilGo. MilGo. All right. So let's try to maybe link with this motherfucker. How about that? So I feel like I have not acknowledged this sub, so let me actually quickly acknowledge this sub. Thank you so much in Lois for Twitch Prime with the message. Hey, New Year, same recreation programming sessions. Dub. Exactly. Athar Vakale 343, thank you so much for Twitch Prime. And Stupid Engineer, thank you so much for Twitch Prime with the message. 2 months, let's go, Penger. Exactly, let's fucking go. So here's the probe libmeal. So what we're gonna do in here is, I suppose, maybe I'm gonna create a separate thing. I'm gonna call it test. Right, and in here I'm gonna create a main.c. So the first thing we're going to do, we're going to just include libmeal.h. Right, so libmeal.h, and I'm going to just try to you know, build it as it is. So let's use makefiles, why not? Why not use makefiles? I'm gonna do clang o main.c. Let's enable all of the warnings and all of the extra stuff, right? And I'm gonna just go ahead and try to build it, right? So it cannot find libmeal.h. So let's go ahead and say that you should find this entire thing in home opt libmeal include, right? So that's the place where you can find all of that stuff. So we tried to build that, it didn't fucking work. So libmeal include, that's very interesting. Is that because I should have, let me take a look at that stuff. Ooh. What? This is not shell. So yeah, thank you so much. Or we could use tilde, right? So, but let's actually do home. So is it going? Yeah, there we go. It built it, right? So, but since we don't use any of the functions, so it like didn't really matter, right? It really didn't fucking matter. So let's go ahead and maybe try to call some of the functions in here. So let's go to home. The first thing we have to do go foo arg1 arg2 or something like that. So I have no idea how to use this entire stuff. So is foo supposed to have some sort of a signature, right? So they just say, okay, wrap foo call into go, and it will automatically work somehow. Okay, so the signature doesn't matter. Is that what you're telling me? I can maybe put some stuff in here. So this is gonna be something like this, right? And so in here, I'm gonna just print those arguments, right? So why not? So I'm gonna put it like that, arg1. So query replace 1, 2, boom. Query replace 2, 3, boom. So, and you're telling me that if I do something like 69 for 21, 37, right, so it will just compile and it will just work. You telling me that? Obviously, it won't work. Well, I mean, I just didn't include stdio. All right. Okay, now we're fucking talking. So there's a linking errors, right? So we need to probably link with the library itself. Okay, so we need some sort of a runtime. Let's go ahead and fucking do that. So I'm gonna do libmeal, I suppose. If the naming convention is right, that's how I supposed to do that. So it's gonna be lib. Here it is, right? So usually like lib is emitted automatically when you do l-meal, so that additional lib is kind of implied. We can actually put a colon in here and explicitly say what we want to link with. Maybe I want to link with specifically static library, so I don't have to deal with dynamic library paths and stuff like that. So if I try to build this entire stuff, it's not going to work because it can't find this scheiße. So we have to specify where you're supposed to search for these libraries. Right, so you're supposed to search them in here, but in lib. Right, so, and now, libs, I forgot what it was. It was not libs. It was lib, actually. Am I going fucking crazy? It's a big, it's L. For some reason, I thought I actually put L in there. Still doesn't work. Okay, so, what if I just say libmeal? Is that what you want? Huh. Minus L, but I already did minus L, so it's libs, okay. Right, so guys, I know how to do programming, okay? I know what I'm doing. All right. So let's actually link with a static one. Okay. So, and we end up with a pretty small executable that, okay, so it actually doesn't introduce any more dependencies than that. Much professional, man. Okay, whatever. So, but this is because we linked it with the static one, all right? So if I link it with dynamic one, I suppose it's going to be the dependency on that, only that as so. Yeah, there we go. And it's not found. This is precisely what I'm talking about, right? So it linked with it, right? But now I have to explicitly point it at the folder where it is located. I could fix that with rpaths and stuff like that, but I usually prefer just like statically link everything, right? So because it just like creates less moving parts, so you don't have to think about like whether the library exists on the machine or not. Just like link everything with all of that stuff. Right, and there we go. So we've got the pretty simple executable. And if I try to run this entire thing, okay. So that Go thingy literally just run it. And I suppose the signature of this thing literally doesn't matter, right? So if I just return 420 in here, right? So it's still going to compile, right? It's still going to compile. All right, so that means Go is some sort of a macro, right? And it wraps this expression into something and just runs it in a separate sort of thread or routine. I'm gonna sneeze, by the way, soon. Debated. So anyway, let's actually take a look at what Go macro does. I think it's kind of interesting. So let's try to define Go. Okay, so when it calls to meal Go, is there like a formatting macro in meal that prints formatted messages and called meal? Anyway, so it's a macro. Okay, so it's an inline macro. As you can see, it creates a body, right? And what does it do in here? It creates something called sp. I have no idea what the fuck it is. So then it creates the meal context, right? Then it saves the current state of the execution in that context. This is what I can see. So there's a meal prologue. So I suppose it is some sort of a boilerplate, but it also returns sp. I still have no idea what is sp, right? So meal here, right? So meals here. I swear to God, is there meals in here? There is no meals in the meal library. What, bro, Martin, why did you miss such a good opportunity to create a MILF variable or MILF function? I'm disappointed. Right, honestly, so far, like not the link, not working link was the biggest disappointment. This was the biggest disappointment. I'm joking. So maybe it's underscore, right? Is there something like mil? Well, I mean, MILF. Yes. MILF dwait. Thank you. Thank you. My inner child is satisfied. Thank you. Thank you so much. MILF dwait. She's waiting for the D. Holy shit. When I'm going to grow up, I have no idea. Anyways, so define Go. So mil Go. So there is some sort of a prologue, right? And MILF's here, right? So MILF here, okay, so this is just a location where you called this macro, right? So we have a MILF string, right? So this is a MILF string, and it's a classical stringify macro, nothing particularly special. So it basically captures the location where you call that macro, right? So everything is classic so far. Some sort of an anchor, right? So, and it's a array allocated on a stack of this size, so then it cannot be optimized. What is unoptimizable? Ah, this is very funny. So they're allocating some sort of an anchor, which is a region in a stack, and they want to make sure that region actually exists, right? So because of that, they say that its size is volatile, so which means that it's not going to be optimized by the optimizer of the compiler, right? So they create a bunch of stuff in here, right? Preparing, this is some sort of a boilerplate, right? So very low level boilerplate, right? They are probably manipulating something with assembly on the stack and stuff like that. And then they call in the expression that we passed in there, right? That's why it works. It is VLA? Yes, it is VLA. Right, so that means it's allocated on the stack, right? So that means this thing doesn't have to be a const value, it could be a runtime value, but since it's on the stack, it's going to work. Right, so here we put this expression that we put into Go, and then we just clean things up, and this is epilogue. Very interesting, honestly. Very interesting. So yeah. So it's all needed so you don't have to do all of that stuff manually, right? So it's sort of like abstracted away from you. All right, that's pretty cool. That's pretty cool. So what else do we have in here? So we create channels. You can create channels, and I suppose they are kind of similar to Go channels. And Go channels, if I remember correctly, they're sort of like pipes through which you can send data, right? So and they become a queue. Right, so usually you have two sort of like threads, but in Go they're usually called Go routines, right? So they're called Go routines, and those Go routines can put something into the channel, so then another Go routine can read that stuff from the channel, right? So we can put semicolon inside the Go macro. Maybe we can, right? So, but then we'll spend 3 hours debugging. Anyways, right, so yeah, let's actually try to create some channels, and let's see what is going to happen. All right. All right, so one warning generated. Okay, so nothing really bad happened. Right, so CHS is equivalent of putting something into the channel, but in Go, as you can see, you can just put that shit into the channel, but in C, with this specific macro, you also have to provide the type of the thing that you're putting in there. All right, so S, I suppose S stands for store, or maybe send, I'm not really sure. But maybe it doesn't really matter. So, but it feels like it's send, right? So channel send, you can send data into the channel, and R probably stands for read. So you're reading this entire thing, right? And then you should not forget to mark the channel as done, right? Which is close, but then also you have to do close, right? But that is equivalent to garbage collector in Go. All right, that's very interesting. Okay. So, you know what I would like to do? I would like to maybe create two Go routines. Right. I would like to create two Go routines. So, this is the sort of like the capacity of the channel, right? So usually you provide the capacity how many like elements you can store in there until things are blocked and stuff like that, right? So what I want to do in here is that maybe create something like producer, right? So this is going to be producer, and it's going to accept the channel like this. And let's actually make it maybe push or maybe send 10 messages in there, like literally integers, right? So it's going to be send this entire thing I, and then, you know, just finish, right? So, and in here, so it doesn't really have to be void. In here, we're going to have a consumer, which also going to accept the channel, but is going to read things from that channel and print them, right? So, and how do we do that? So this is the choose, but I suppose something like CHR should be enough, right? So I should be able to just do something like D, CHR, CH, right? So, and yeah, I wonder for how long can I do that? So I obviously need to do that indefinitely, right? I must do that indefinitely until it's closed or something, but how do I know that the channel is closed? So I suppose one of the things I have to do is maybe do ch done, right? I must do ch done on the producer, and then I close the channel. And that means on the consumer end, something will happen with the channel, so it will be marked as closed or something. This is my hypothesis, but I have no idea how to do that. So they don't actually tell you this function in here at all. And honestly, this example is kind of meh, right? So because it's not a complete working example. But we can try to maybe go into the libmil, right, and try to find somewhere nearby some of the functions, right? So deadline, so you can duplicate some of these things, you can close, you can send, you can read, you can do done, in, out, have no idea what the fuck is that. And this is probably the choose stuff. But I honestly don't see how to check whether the thing is closed. Maybe Closed? No, it's just close. TCP. They have explicit support for TCP. So that means with this library, you can already do networking, right? So without writing your own stuff on top, right? So it just like already have like adapters for TCP connections and stuff like that. So you can do asynchronous stuff in Echo Server. Echo Server is the new meta. Who fucking needs Raylib? Raylib speedrun? Fuck Raylib speedruns. Echo servers. Echo servers are the new meta. This is fascinating, right? If it works, why it's not developed? Why it's like, I guess like once you have Go, nobody really needs this kind of stuff. But I mean, it's kind of cool. Echo Server is the new hello world. But to be fair, Echo Server is basically the hello world of asynchronous programming and networking, right? Isn't it? Next, write channels in Jai. Well, yeah, Jai can pretty much do anything C can do. So I'm pretty sure you can have channels in there, and maybe you can even have them in a more convenient way because there is a really powerful meta programming, right? So they could be actually as convenient as in Go, right? So it's just like it depends on how much effort you put into the library in Jai. So Why Software, thank you so much for the tier 1 subscription. So Krusty, thank you so much for tier 1 with the message. Panger waving, thank you. Lendra Braga, thank you so much for Twitch Prime. Thank you, and welcome everyone. So how do I know that the channel is cooked? How do you do that in Go, by the way? So because I don't really know. So go check if channel is closed. Is there any way to do that? How to check a channel is closed without reading it? So if you try to read it, right? So, right, if you try to read it, maybe it will fail. Okay, so let's actually just go ahead and try to run this entire thing, right? So let's just try to run it, and maybe it will crash if I try to read the closed channel. Maybe that's what happened. So anyways, the first thing I'm gonna do, I'm gonna just do the producer ch, right? So I'm gonna just call it like that. Maybe it would make sense to actually print what we're sending. So printf producer d. So that's what producer has sent. Right, so this is what the producer has sent, and this is what the consumer has received. So this is how we're gonna go about that, right? So I think it makes sense. I'm gonna run only producer now, only producer, no consumer, right? Just see what's gonna happen. All right, so it doesn't compile. Let's see what's going on. So I supposed to provide the type in here, so that's understandable. What else do we have in here? So there's no true, understandable. Let's provide the true. Okay. What else do we have in here? So CHR also accepts the type of the thing you're trying to read. Understandable. All right. So in producer managed to do only 0, and then it just finished. Right. So let me make sure that I didn't make any mistakes in here. Right. So here is the loop. It's supposed to do 10 iterations. It managed to do once. It tried to put something into this channel, and then it just died, right? And it literally exited with a 0 code. This is fascinating. I wonder if this is expected behavior if I only run one core routine. What is going to happen if I try to now provide the consumer, right? So I run producer and consumer, right? So what is going to happen? Nothing happened. I wonder if there is some sort of a function that says start, right? So, you know what I mean? Essentially, you just register those things. It's not coroutine. Yeah, exactly. It is not coroutine. Maybe I should call something in here. So it only compiled, it didn't run. Yeah, I understand. So there should be something. Channel capacities. Okay, let's go back then. So let's actually put like 100 in here. Right, let's put 100 in here and try to run this and that. Okay, right, so that didn't change anything. So the capacity 100, that didn't change anything, but now with the consumer, So we managed to send that to the producer and to the consumer, but the consumer didn't receive anything. Right, so and then we managed to send the second one, so we went on the next iteration, and then we kind of stopped or locked or something happened in there. Fascinating, fascinating. So I feel like this is not how we're supposed to do that. All right. So thank you so much for all of the subs. We have a lot of subs today. Gao Gao QWQ, thank you so much for tier 1. Mr. Force, thank you so much for Twitch Prime. Core Dian Corp, thank you so much for Twitch Prime with the message. Today, another chunk of SAS tricks to make C language superior in the future. Rust style memory management, but in C. Honestly, I don't really know how to implement borrow checker in C without like an, external preprocessor of some sort. I think you need to wait in main. That's a good hypothesis. Right, so essentially I can look into the documentation, but I kind of want to try to figure it out. Right, so because it's kind of a testimony to how intuitive the library is. Right, try run consumer first. Yeah, we can try to run the consumer first, sure. Nah, didn't do anything, but it runs some stuff in the producer. Right. So we can try to sleep for 1 second. Okay. No, didn't change anything. Didn't change anything at all. I wonder if something is broken in the library. Right, so because we actually downloaded the latest version of the library. Right, what is breaking the while loop? I have no idea. Something is breaking, right. So let's actually try to grab the latest release rather than the cutting edge version. So let's actually go here, and so we have some untracked files, which is just build, nothing particularly special. How can I fetch the tags? Okay, so let's fetch all of the tags from origin. So hopefully that is going to work. All right. So what was the latest release? It's kind of difficult to tell, but we can take a look at the tags in here. So 118. Okay. So 118. Can I just check out 118? So all right. It's basically the previous one. So they merged some pull request. Fascinating. I wonder what the fuck was this pull request. That's actually a lot of changes if you think about that. That's a lot of changes. Right, so, and this thing was actually 8 years ago. And so I'm actually, maybe it's a hacked version and my computer is hacked already. So what was this pull request that emerged 4 years ago? This fixed issue when can be compiled or GCC but fails, but it's actually... Maybe it's something with my Git in here that is sus, so it's kind of difficult to see. So yeah, it hasn't been touched for like 8 years. And by the way, it hasn't been touched by 8-9 years, and it just compiled on my machine. It just compiled on my modern machine. Actually, this is the latest Void Linux and stuff like that. Can your web infrastructure do that? Can it survive at least 1 week of updates? This motherfucker survived almost 10 years. Another star. Yeah, so it deserves another fucking star. So I'm actually not sure that I can simply switch to other commits in here so easily, because this is a shallow clone. I think first thing I need to do, I need to unshallow the clone, but I don't remember how to do that. Git unshallow clone. So let's actually quickly do that. So I'm gonna go to the master. How to convert git shell. There was one command, I remember that. So, but yeah, it's just fetch unshallow. All right. So let's just unshallow the clone. I didn't want to do that because I thought, right, that is going to take too. It didn't take too long, honestly. Right. So that was relatively fast. All right. So 4 years ago. All right, so I'm gonna go here. So now we are here. So there was a couple of fixes and stuff like that, GCC9 compilation fix and so on and so forth. So now what I want to do, I want to just rebuild everything, right? So in here. Ooh, so that's why you needed this fix. I guess C can't do that, just like a web environment. So you need to explicit. Oh, okay. So I got too cocky too soon. So anyway, so that was the pull request about. That's what it was about. All right. So the fixed compiler flags for Windows build and then GCC build. Right. So okay. So let's actually see. Is it compilable? Nah, it's still not compilable. So where's the log? And we can go here. So let's go here and try to rebuild that. Yeah, okay. So we can't even build the previous versions, right? So we can't even build the previous versions. So that this is what we stuck with. Okay, so I'm gonna dismiss the idea that maybe it's broken in the latest release, right? So we're not going to consider that idea at all. So that means I'm just like using it correctly. I'm holding it incorrectly, right? So just like any Apple product. So documentation, introduction. So how the fuck do you do that? Okay. Why this is not on the front fucking page? Bro. Okay, so yeah, I should not be too harsh on this library because again, it's kind of abandoned, it's not actively developed. But I think this should have been on the front page, right? So yeah, at least this is the first thing, by the way, I asked when I looked at the front page, like, how do I define the worker, right? So just like how they define it, right? So if it was on the front page, that would have been easier, right? So I would have wasted less time. So let's take a look. So I suppose the only thing I need to do in here is just like put coroutine in here. Okay. So, and let's take a look at libmeal.h. So what is a coroutine? It's definitely, it's an attribute non-inline. Okay. So you have to make sure that it's non-inlineable. Otherwise, ooh. And you do in fact have to sleep. You do in fact have to sleep. Right, so yeah, let's sleep a little bit. I wonder where msleep is coming from. Msleep is their function. Okay, so it's their function that you have to use. And what does it do? I don't see where it is implemented actually. So L expert. Oh, it's the header file. Right, what does it actually do? So it does something internally. Let's go to libmeal in here. And let's find where it is defined. So it's a polar. So it does have dwait. Current is, I suppose, I don't know what the fuck it is. libmeal.h. It's the current location, right? So it's at this specific location. It does fd wait. Milf waits for the d. Milf waits for the D, so okay, this is not a regular sleep, by the way. This is a little bit deceiving. This is straight up deceiving, right? So because it makes you feel like just a regular sleep will work, right? So Milf sleep. So just a regular sleep will work, but it won't. You have to specifically use their Milf sleep. You have to sleep with their Milf. Right, because look, it does a lot of internal stuff, right? So it's polling, it's rolling, it's roly polling, right? It's doing all sorts of things with your MILF, right? So this is a little bit deceiving. Maybe it should have not been called sleep, right? So because it makes you think that it's just like doing nothing. In fact, it's kind of like polling things, right? So it's a polar. So that's one criticism for the library, I would say, that it's a little bit deceiving. Right, so okay, but I mean it's fine if it works, whatever. So this has to be coroutine, and coroutine is not really that important. The only thing it does, it just ensures that this thing is not going to be inlineable, right? So then you have an opportunity to make it take a pointer of it or something, right? So I don't know, but anyway, so we do msleep. So, and what's funny is that you provide a timestamp. You provide, that's why it was called deadline, by the way. This is why it was called a deadline, because you don't provide how much you sleep. You provide until what point you sleep. So you're kind of scheduling. It's a real-time system. You give it a real-time, like, deadlines and shit. That's interesting, like a... Is that a thing? Is that what people do in these real-time systems? They don't sleep a certain amount of time. They sleep until very fixed deadline. Right, specific fucking deadline. So let's go ahead and try to do that. Right, so this is fascinating. Chat, this is fucking fascinating. All right, so this is what we have to call, right? So now I understand that. I perfectly understand that. And now let's try to run this entire thing. This is fucking cool. So yeah, it's it worked. The scheduling is kind of weird, right? So first it sent two things in here, and consumer kind of received them a little bit lagging, but I mean, they're interleaved. It works. After fucking 8-9 years, with only fix of, fixing the compilation errors and stuff, like, it works. At the end, we have some sort of a panic. Receive of type not matching the channel. So I presume this is because the channel was closed, right? So this is what I presume the reason. So one of the things we can do in here is like have the same amount of iterations as like in consumer as in producer, right? And in that case, it's not going to panic. So it only panicked because we tried to do this extra read from the channel. That's the only reason it panicked. And this is why I was asking, how can I just check that the channel is not closed or anything? So yeah, that's kind of cool. That's kind of cool, actually. All right. Meal go. It's just like without a go. I don't know. Like, what's the difference between just a regular go and meal go? So coroutines, like we already know that this is a coroutine. Select, yeah, I probably have to do select. That's for sure. You can do fucking yield. You can yield to the next coroutine and shit. There's a lot of text, probably useful, right? And I probably want to read it, but I don't want to read it on the stream. But maybe I could read it on the stream, I mean. So coroutine is defined using coroutine keywords and launched using Go construct. Okay, so that's understandable, we already know that. Although coroutine can return a value, keep in mind that it is executed asynchronously and thus there is no way to retrieve the result. Understandable. Note that your program may work perfectly well even if you omit the coroutine keyword. Yeah, so we already know that. We already looked how the coroutine keyword works. It just adds the attribute non-alignable. However, such program may break randomly when compiled by different compilers or with a different optimization levels. A known problem is with Clang and O2 optimization levels. Understandable. So also bear in mind that coroutines are scheduled in a cooperative fashion. If one coroutine blocks, for example, by calling sleep, it blocks the entire process. Therefore, coroutines friendly versions of blocking functions such as msleep and fd see below should be used. Okay. In case of need, that's really weird English. But anyway, you can yield CPU to other coroutines explicitly. This reminds me Windows before being like a separate operating system, like when it was like a desktop environment for DOS. I think it had like a similar cooperative multi-processing or something like that. Right, so each process had to explicitly, yield to the next one or something like that. Go before 114. So go before 114 was like that, right? So you also had to yield things. This is actually kind of cool. This kind of gives me a couple of ideas. So essentially, things like CHR and CHS probably yield implicitly. Do I understand correctly? They probably yield implicitly. So everything is executed up until CHS or CHR or explicit yield. Then the schedule switches to another function, right? Executes a little bit until another switch, and so on and so forth. You can check, that is true. That is actually absolutely true. So CHS, all right, so this is the function, and that means I probably have to go somewhere here into the source code of this entire stuff and just like grep this entire thing. So Chan, All right. So what do we do in here? So meal slow, right? Null channel used. Choose init chs struct close choose wait. It calls to wait, but I have a hypothesis that maybe yield does a similar thing. Maybe it does a similar thing. So yield, right, it's also a function, right? So, and it's not defined within chan, right? So let's try to grab this entire thing. So where it is defined, and it does suspend but not wait, but maybe they're kind of related, right? So I'm not sure. This looks fishy, but yes, we can resume the coroutine even before suspending it. I really appreciate the comments like that. Very well done. Very well done. All right, so I think I understand the gist of this library. So the thing we want to do, like G Blow style, yeah, so Jonathan Blow style. So we probably need to do select, right? So let's try select. So you do choose out ch int. So yeah, I don't remember how to use this entire shit. So then you do end and some other stuff. And I suppose, so on the default you just do something else. But one of the things you can do with the channels, like you can just never finish, right? So we kind of have a really weird use case in here, right? Usually you have a service that is just like serving things and it doesn't really need to be finished. And if it needs to be finished, I suppose usually what the producer does, it sends the termination message of some sort. And this is something that we could do in here as well, right? So we could do something like int -1, right? And instead of doing this kind of thing, right, we can just do true. Right, so, and then we do something like int x, and if x is less than 0, then we just simply return, otherwise we print x, and that's basically how we can do that. We don't really have to explicitly know whether the channel is closed or not, like it doesn't matter. So if you try to read from a closed channel, that means it's sort of like an exceptional situation. That means your protocol between coroutines didn't communicate properly. This is just my hypothesis. So maybe in Go you also can't really do that, right? So you're supposed to just coordinate and cooperate properly, so you never really need to check whether the channel is closed. Do I understand the philosophy of Go routines and Go generally correctly? Right, so context done with select. It's probably done with select. Maybe, I don't really know how select works properly, so... My entire bot, by the way, is written in Go, but I still don't fucking know how to properly use channels. So I think the ch calls goes together with this ch make. Yeah, that's probably true. There's also ch done, which can accept integer and 0, which is rather bizarre. So, which makes you question, like, what exactly is that? So libmeal .h ch done value size, and does it just like send it as a last value? Maybe that's what it does actually. So essentially maybe what I could have done in here is just like remove this thing and just do -1, right? So is it going to work? Nah, it doesn't. I was thinking maybe it just sends that value in here. So also, a closed channel is a common thing, yeah, I suppose. So I suppose I have to do select thing and stuff like that. But maybe there is something in the tutorial for that. So let's take a look at this. So business logic. Oh, this is already TCP. Well, let's not do that yet, right? So we're gonna go into TCP at some point. Right, so yeah. Making it robust, maybe internal. Documentation. Channels. Okay, so this is how you create channels. When sender is done with sending, it can announce the fact using ch done function. The value third parameter passed to the function is used to signal to the receivers that sender is done. Once all the actual messages are read from the channel, any subsequent calls to CH won't block and will return the specified message instead. But this is... wasn't it exactly what we did in here? Right, so I just did that, but I didn't receive that thing. Yeah, I didn't receive it. Like, what the fuck? Excuse me. Maybe this is because I closed it. Right. Because I closed the channel. So who's supposed to close the channel then? So is that the consumer? The code received side typically looks like this. The code on the receiver side typically looks like this. Okay, so you receive this thing and then break. To deallocate the channel, use CH function. Note the CH deallocates any element remaining in the channel. Oh, it's deallocated. So I suppose I have to probably close it in here. So I close it in here. But this will only work because I have one consumer. So we have several consumers. This is kind of something that shouldn't do. CH close, CH. Right, so if I try to do something like this, it works without any problems. So if I have several consumers, I probably have to do it somewhere here, honestly. Probably have to do that somewhere here. But if I'm going to be doing it somewhere here, that means I have to pull it in here. Right. But I don't have to pull it in here because I have sleep. Right, so because this thing will kind of block for this function for this amount of duration. Right, it will block for this function for this amount of duration. And yeah, that's it. And usually you have channel per consumer anyway. Right, so yeah, I think I understand how it all works. Right, so I think I understand how it all works. Okay, so I think I'm mentally ready to write an echo server chat. I think the time has come to introduce an echo server. All of the servers were not echo friendly. Right, so, but I need to make a small break and refill my cup of tea. Right, so because I'm streaming for an hour, right? So the time has come to make a small break. And after the break, we're gonna look into the networking capabilities of this library because it does have some stuff, right? So as you can see, network. Right, so IP address. To use TCP or UDP, you need IP address first. The wrapper type for IP addresses, both IPv4, IPv6, is called IP address. Right, it also includes port number, unlocks addresses, blah, blah, blah. There are two functions to construct IP addresses. Okay, so it has its own sort of wrappers and everything. So, which is kind of fucking cool. Right, which is kind of fucking cool. So you can do like a while loops in here and everything and stuff like that. So anyway, let's make some break and all right, we are back. So let's go ahead and try to implement the echo server. Right, so this is going to be the final testimony for the library. Can I implement a proper echo server which is asynchronous and doesn't create a thread per connection? Right, so let's see if we can do that. So here are the networking capabilities, right? So we can actually see them. The first thing you have to do, you have to create an IP address. Right, so IP local. Oh, you can even provide the interface, which I'm not even sure, like, we need that. That's really weird. But I mean, it's an IP address, so that means on the level of IP protocol, right, so yeah, we don't really create any specific address or whatever, I don't even know. So... I suppose if you want to work directly with IP protocol and IP addresses and stuff like that, because IP is rather like a low-level protocol, right? You can't really do much with this protocol. So speaking of TCP, it's just an intermediate step before you connect somewhere. Okay, that makes sense. So we can be listening to incoming connection, and we can be listening on a certain interface, or we can be listening on a certain address, and so on and so forth. To start listening for incoming TCP connections, use TCP listen function. To accept new connection, use TCP accept function. I wonder, like, do I do that in a separate coroutine? I suppose I do that in a separate coroutine. So I want to actually store, like save this entire thing. Right, so so this one is basically first. Let's call it just first. Right, so, and let's rename this entire thing to first. This is our first example using libmeal. And I suppose another thing we need to do, we need to copy paste this entire thing, and we're gonna call it something like echo, right? So this is going to be echo. And if I want to build all of them, I'm going to build building first and echo. So I suppose I want to maybe factor out all of these flags into C flags, like so. So this is our C flags. C flags. And this one is also C flags. So we need that so they don't look too scary. And all of that, I think it's usually called libs. Right, so this is the libs. A little bit of Emacs magic, as usual, and there you go. So now, if I do G2 minus B, there we go. It couldn't build anything because there is no such thing as echo. Right, let's create it first. I'm gonna go to the first, and because I want to just steal a bunch of things in here, right? So I'm straight up stealing from my own source code. And I suppose I can already try to build this entire thing. So minus J2, it actually runs in 2 threads. So both of these executables are going to be built simultaneously. And minus B basically doesn't do incremental build. So no matter what was rebuilt or not, what was not rebuilt, it will rebuild everything, right? Regardless of whether it was changed or not, right? It always rebuilds thing. Yeah, that's what it is. So just in case. So it doesn't cache anything. Okay, so we can try to create maybe server, right? So it's going to be coroutine, and this is going to be server, right? We're not going to accept any channels, I suppose, at least for now. What we're going to do here, we're going to organize the loop, right? So we want to first create the address, and I think I'm going to be listening right now only to local connections, right? And obviously I'm going to be listening to the port 6969, obviously, and 0. What the fuck is 0? So, so what does it take? So local address gets IP address remote in addition to certain. It's not obvious right away what the fuck is this third argument and why it is 0, but we can take a look at this thing. Right, it's a mode. Okay, so maybe we're going to be using a default mode, and that's why it is 0. Understandable. Perfectly understandable. So where is the listening and shit? So the next thing we do the listen, and if I remember correctly from just a listen syscall of Linux, this is a backlog, this is the size of the connection queue or whatnot, right? So here we set 10, let's set 69 here. So, and this is a TCP sock, this is the listen, and then what we do in here, we in an infinite loop just accept connections. Right, so we accept connections. I don't really remember what is -1. Right, so let's take a look at the accept syscall. Right, and it's an address, I suppose. Right, so usually in the original syscall in POSIX, you can specify the pointer to the address, so you know the address of the connected socket or something like that. But here you provide -1, which is rather interesting. So we can take a look at what the fuck is TCP accept. Yeah. Oh, it's all right. In the MILFs library, this is not an address of the connected socket. It's actually deadline, and then we provide Wait a freaking second. You can provide -1 as a deadline, so that means I don't have to sort of like allocate enough memory for all of these things to finish. I can simply do -1. Is that what you're telling me? I can just do sleep my... Really, Brovsky, what the fuck? What? Why wasn't that told me? Why didn't they told me that right in the front page of the website? Ah, I see. I see why. Yeah, because this msleep does not finish sleeping after all of the coroutines have died. Right. So as you can see, both of them have died, but we keep sleeping. All of the coroutines have finished, but the MILF keeps sleeping. I'm so fucking sorry, chat. The true sleep grinder. Okay. So, but maybe it can be useful. How can you get out of the sleep, though? I think you can try to panic. What if we try to panic in here? Let's go ahead and try to panic. Right, so we're gonna do that. Ah, look at that. Oof, 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 oof. So that means what I have to do... Yeah, it's a valid strategy of actually, you know, waking up after an infinite sleep, just panic, right? So just like forcefully. Okay, but let's not do that. Let's actually go back. So I suppose you do need deadline in here. But for the echo server -1, we can just keep the infinite deadline, right? So we can just keep an infinite deadline. And I suppose, yeah, so it's a timeout for accept because it's kind of like a asynchronous and stuff. But I expect that TCP accept is going to switch to other coroutines while we're waiting for the connections, right? So after that, maybe we can print something in here, accepted conniption, right? So accepted conniption. And I wonder, like right now I don't really want to do anything with the conniptions, so I think I'm gonna just close. Can I do TCP close? I feel like I can. So TCP close. Yeah, I actually can. So it is a thing that I can do. And then I can just repeat that and continue accepting the conniptions. Right, so something like that. So and in here we can maybe even do some nice stuff. So this is the host. We can just save that to host. So this is the host, and in here we want to provide the port. But what's the type of the port in here? What's the type of the port? It's just integer. Okay, I really like that, because usually some of the implementations, some of the libraries accept specifically unsigned short. Right, so because ports are shorts and they're unsigned, so the maximum value that you can have in here is actually what, 2 to the power of 16? Yeah, so that's the sort of like the maximum value. I suppose it's actually -1. Right, so because of that, they want to reflect that in the signatures, and they only accept unsigned short or whatnot. This library being kind of liberal about that, so they're just being a chill guy library. Like you wanna put an integer there. Here we go. It's an integer. Don't worry about this unsigned shorts and all of that nerdy shit. We accept integers. Just fucking relax. You can put -69 in there. Yeah, exactly. Thank you so much. So who fucking cares? All of these, like, you know, sizes of integers, signers and unsigners is for fucking nerds. Nerds, fucking nerds. JavaScript being a chat language, it's just all flows. It's just all flows, because real chat software developers ship shit. They don't think about the sizes of integers. They gotta ship. They gotta fucking ship. They have no fucking time to think about integers. Have no fucking time. That's why everything is flow. All of that shit is for nerds. Fucking nerd. I should... too much tea. So what I want you to do, I just want you to like create separate variables. And the reason why I want you to create separate variables, so then I can use them in logging. Right, so I can now just start listening, right, and say listening to S and D. Right, S and D. Maybe Linux kernel should change ports to be flows. Fair enough, fair enough. Was some sugar in the tea cup? Surprisingly, I don't drink tea with sugar, right? So I think it's a purely coffee, right? So, anyways, you haven't seen me on sugar yet. So yeah. So this is what I wanted, right? So that's why I needed reusable variables and stuff like that, because I want to have some sort of a logging, a pogging. So let's do go server, and let's actually sleep indefinitely on this one, right? So because we can always just like Control-C this mother flipper, right? So let's go ahead and just do echo, boom, and we're listening to this entire shit. And then if I do telnet, boom, man, fuck you. This is so fucking easy. Bro. I hate how easy it is. Like, what the fuck? Excuse me. All right. So that means coroutine void client. So, and I suppose here we have to accept the TCP socket, right? So here's the TCP sock, and it's going to be client, right? Maybe we can call it S, right? So, and essentially when we accept the connection, we just do go client S, and that's it, right? So, yeah, we can even put this kind of stuff in here, right? And in here we can do TCP close. So essentially it is done in a separate routine, right? So we just do go client. So there's one routine that keeps accepting connections, and then this routine just like handles them and stuff like that. So, and if I try to build this entire thing, right, compilation interrupted, everything builds. So, and in here, I suppose what we have to do now, we have to read some stuff, right? So here we're sending data, it doesn't matter. We can receive the data. Okay, so let's pre-allocate the buffer. We can pre-allocate the buffer on a stack, right? So let's allocate 1 kilobyte. So this is our buffer. We can do just receive, I suppose. TCP receive. Where is the nice wrapper? Parappa the wrapper. Holy shit. This is a perfect name for utility for generating bindings for libraries or something. Parappa the wrapper. Oh my fucking goodness. Has anyone actually used that name for a bindings generator of some sort? You know, the wrapper. This is fucking genius, I like it. I'm sorry. Yeah, kick punch, it's on the mind. So let's do that. So here we have to provide the buffer. Also, we have to provide the size of the buffer. And here, let's just set infinite deadline, because who fucking cares anyway? Who fucking cares? So this thing returns the size, right, so this is probably n how much we received. And essentially, we can just print that stuff, I suppose, right? We can say the client send this thing, right? So, but we also have to print it as a sized thing. So that means we have to put n, and it accepts integer specifically, and a buffer in here. And let's also not forget to do this kind of stuff. So also let's do while true. This is while true, and we're gonna put it like that. So it's a little bit of unreachable code, but that's fine. That is totally fine. So let's try to rebuild it. Okay, so that seems to be working. And now let's try to do this kind of thing. So what do we have in here? So this is a telnet. Okay. Hello. And that didn't work. All right. So this is the ooh. That is fascinating. So it didn't switch to the next thing. Chat. It didn't switch actually. Right, so one routine created another one, but there was no switch. I wonder if I have to explicitly do yield on this one. Is that something I have to do? Just do go and then yield? Recursive. Buff should point to buffer though. What are you guys talking about? Anyway. So what was it saying, by the way? Yeah, client sent hello, and then something is weird with receive. So it kind of blocked and we didn't receive anything. So I'm not really sure. So receiving data, similar as we sent, returns number of bytes received, and the value should match the number of bytes requested. So there is a receive until. So that's a very interesting function. So it just like makes sure that we read this exactly, yeah, exactly this amount of bytes, except that the read stops when one specified character is encountered. Oh, that's interesting. Maybe that's what we should have done. Right. So it reads until new line, for instance. Go routines on a single line. Yes, exactly. They are on a single thread. On a single thread. That's kind of the point. So in the runtime switches between them constantly, sort of simulating, you know, a parallelism, but it's not really parallelism, it's concurrency, right? So, and that way you can do asynchronous, like concurrent code without introducing, like without switching the paradigm, right? You're still kind of programming in imperative synchronous style. Right. I wonder like what happened in here, right? So because here I just did accept and I just created a new thing in here and that's it. Did I have to do something else? Or maybe, you know what, maybe creating coroutines like that is not really a good idea. What I probably should have done is maybe have two coroutines, right? Two coroutines. The one accept connections, and as soon as it accept connection, it sends the socket to the client coroutine, which already kind of handles it. So this thing should be already pre-created, and maybe this thing should handle several connections. But then how does it handle several connections? So yeah, that's bizarre, honestly. That is bizarre. So for instance, I want to do a little bit of a test. What if I create a coroutine, which is a counter, right? So, and what it does essentially, it just like, you know, counts things. Right, counts things. Maybe each second or something. Right, so here, so we should print accept connections, right? Printf accepted connection. And so I suppose maybe we're gonna just continue printing indefinitely. So we print ZU, but maybe it's gonna be just D because it's an integer. So this is that. So we're just doing something like that, and we're gonna be sleeping now plus 1 second. Right, so 1 second we're gonna be doing the count. Right, so and in here, every time I accept a connection, I simply start the counter, but it doesn't really accept the socket. Right. So I just want to see if the coroutines created from the server coroutine actually exists and actually like working and counting and stuff like that. Right, that's what I want to see. So it's rather interesting, like what is going on in here. Okay, so we're listening, and if I try to do telnet, all right, so it is counting. Right, and while it is counting, can I accept more? I can accept more connection. Now we have two counters. Right, and then can accept more connections, and we have now 3 counters. So it is working like roughly as expected, actually. Right, so yeah, I don't see any problems, honestly. That's kind of funny. So yeah, as you can see, there is a scheduling, there things are going on. Right. That's really funny. Is that because, yeah, so let's go to the client now. All right, let's go to the client, and I just do client S, right, and this is where it stops working. Maybe I should have done something like TCP receive until, right, so maybe this is what I should have done, count maxing. Right, I'm count maxing. So this is the delimiter counts. Yeah, so essentially I have to provide buff, then I have to provide the delimiters, and the delimiter for our case is going to be new line. The amount of them is going to be obviously 1, and the deadline is going to be -1. And then every time I receive the thing, I'm going to be just like printing it in here. Right, so maybe I don't even have to have new line in here because the new line is going to be in buffer or something like that. So if I try to now build the whole thing, will I be able to just do telnet? Okay. All right. Okay, so that seems to be working. So then I do telnet. Okay, so that's pretty cool. So let me close that. And something is really weird going on when I just close this entire stuff. And it also doesn't really accept the connection right away. Right, it doesn't really accept the connection right away. Only when I send some data, then TCP accept wakes up. Is it blocking until buffer is full? No, as you can see, this is not what happened. right? So because we were receiving some messages, like in here. But maybe TCP receive specifically actually waits until it's full. So let's actually read about it. TCP receive. Right, so first argument is the socket reads the data from TCP. Second is point to the buffer. Third argument is the size. Well, I mean, if it was waiting until the full buffer is read, it would not return the amount of things read. So, do you need to handle n equals 0 in client? I think I do. All right, so if n equal to 0, return. Actually, break. Yeah, let's give it a try. So maybe this is what happened in here. So let's do that. So because, yeah, I forgot about it. Thank you. So thank you so much. All right. So that's pretty cool. Okay, telnet hello. Okay, the client sent hello. We can actually send probably several of them. All right. So then I can close this connection. It was it. Thank you. Who said the equals 0? Alex Over. I'm gonna give you VIP. Why aren't you VIP, Alex Over? Because you've been helpful really very much in the streams. Okay, so and here I can close the connections as well, so everything seems to be working. So we can even maybe log this entire stuff, right? So client closed the connection. There we go. So that's pretty cool. But now I feel like what we need to do in here, we need to actually send that data back. Right, so we need to send that data back to be proper echo server. Right, so let's go ahead and do that. TCP send, and let me see, TCP send. So it accepts only buffer, length, and deadline, and the usual stuff, right? So this is the buffer, this is the length, and the deadline is going to be -1. So it also probably returns how much it's sent, right? So, and if it's sent n equal to 0, we also break in that case as well, right? So it's kind of a common situation in here. All right, so let's give it a try. Let's restart the whole thing. It doesn't compile, look at that. So TCP send declared here, socket buffer protocol. So I think I forgot to provide the socket. Yeah, that's true. Understandable. Thank you so much. Thank you. Right, so telnet, hello. We didn't receive the hello back, unfortunately. So I have no idea what the fuck has happened. Why we didn't receive back? That's bizarre. That's bizarre. Do I have to flush somehow? TCP send. Yep. To optimize through may store the data into our TCP flash. Freaking flash. Okay, so we have to do flush. All right. So does it return anything? Doesn't return anything. TCP flush. So this is the S. Yeah, just flush, and you have to provide the deadline as well. Right. So let's try to restart the whole thing. Hello. Holy shit. We got a synchronous echo server. Look at that. So telnet world. Okay. So what about the htop? It's that fucking easy. Without a horrible... it's literally Go. Look at that. It's literally Go. Right, so here I just accept connections and just do Go client and then pass it there, and then in the client is just like... Who needs Go? Like, it works. And it's convenient and shit. Right, and... What the fuck? It's a almost 10 years old library. Think about it. And it hasn't been updated much. It's basically the development has stalled, right? The only changes that this library had in the past 10 years were basically fixed for the latest compilers, right? So because apparently the latest compilers broke some compatibility or shit like that. Freaking classic modern software development. But it still works. And it works just like Go. Like, what the fuck? This is so fucking cool. Like, this deserves like a 2 stars. Seriously, go start this library, like, holy shit. This is so based. The library, the idea of the library is fucking cool. The implementation is fucking cool, and it works after being abandoned for 10 years. Just fucking think about that. Well, I mean, yeah, so there's some latest changes like 9, 8, 10 years, right? So honestly, like since it's kind of abandoned and since there's like download links are not working and everything, I didn't have any high expectation on this library, right? At the beginning of the stream, you saw that, you heard that, I said that I don't really expect too much from it, right? So because it's probably like a recreational thing. But this thing just surpassed all of my expectations. Like it's just like, it works. You can use it for some stuff. Like the next time I need to create like a server, like a synchronous server to serve some things, like I'm probably gonna be using this library. That's cool. What the fuck? What a based library. I wonder what else does it have. So it has networking. Okay. So does it have anything else? Right. You can work with Unix sockets and stuff. So there is a mfread. Please note the file operation, if blocked, will block all running coroutines. Oh, it's just like for general blocking operations. I guess it doesn't really have anything except for just like channels and networking. Right. So it just has this explicit support for networking. But I think honestly, like it's kind of enough, right? Do you really need anything else? Usually you need asynchronous stuff specifically for the networking anyway. Time to make WebSockets in C again? Well, I mean, the WebSocket library in C3 that we developing in here, right? So C3WS, so this library. I'm gonna put that in the description for YouTube people who are interested. It was translated from a C library that I developed, CWS, right? But to be fair, the development of C3WS is more advanced than the original library, right? So this thing straight up passes the Autobahn test suite, right? So and Autobahn test suite like tests the WebSocket protocol implementations very extensively, and it passes all of them, like it's with flying colors. The only problem with this thing is just it's synchronous, right? It's not asynchronous. This thing doesn't pass shit. One of the things I can do, I can take whatever I developed in this library and kind of backport it back to here, and then make it asynchronous with libmil. Does the CWS use thread? It doesn't use anything. It's just like a very dumb, very naive synchronous implementation. The author made a SQL library. Okay. So let me see. So this is libdeal.org. Okay. Oh, it's. What's the difference between them? Is it actively developed though? Is it actively? Okay. I'm gonna put that in the description as well. SQL to mil. Wait, so this is a DILF library now. Holy shit, we got a whole family in here. But I mean, I feel like so far I can use it as a drop-in replacement for MILF. Right, so DILF is a drop-in replacement for MILF, essentially. So, okay, let's do a comparison. Can I download this thing at least? Alright, so can I download this thing? So maybe I'm gonna put it in here. Alright, that's an obvious improvement from MILF, is that the download link working. Okay, so the library has improved, obviously, the download link working. Okay, so let's unpack this entire thing. And does it have CMake? It doesn't have CMake. Another improvement. This is the second improvement. It doesn't use CMake. It only uses AutoTools. Okay, that's pretty cool. So let's take a look at the configure. So configure help. All right, so let's see. So does it have a prefix? Yeah, well, I mean, configure script usually have prefix. So let's also install it at home, opt libdeal. Right, so let's do configure. Oh, Emacs has a highlighting thingy for the configuration scripts. That's pretty cool. So let's build the whole thing. All right. And it doesn't build. Well, nothing much to say. Maybe if we take a look at the GitHub repository. Let's take a look at the GitHub repository. So there's some also changes from 3 years ago. Okay. So retrieve OpenSL. Maybe the thing I have to do in here, it's also thousands of commits. So Bro literally re-implemented the entire library again from scratch with the same interface. That's dedication. Check FAQ. All right. So where is the FAQ? Okay. Meal. Okay. Different from. Was a project that aimed to copy Go's coroutine model in C one-to-one without introducing any innovations or experiments. The project is finished now and it will be maintained but won't change in the future. Oh, okay. The DILF is a follow-up project that experiments with the structured concurrency and diverges from the Go model. Technically, these are the differences. Okay, so this one is really interesting. libdil is idiomatic C, whereas libmeal makes Go concurrency API and implements it in the most identical manner in C. libdil tries to provide the same functionality via a more C-like and POSIX-like API. For example, choose is a function in libdil rather than a language construct in Go's panic is replaced with error returns. Okay, so there's not that much difference in there, right? So there's sort of like ideological, philosophical differences and stuff like that. Oh, and they have a WebSocket implementation. Look at that, apparently. Just a second. Oh, yeah. So, that's really funny. Okay. So they... Cool. But I mean, I can't compile it with my modern compiler, right? So I need to at least test. Right, so just see if it's compilable at all. Right, so let's remove this entire thing. So let's git clone the whole thing. I'm gonna clone the entire thing, not shallow clone it. Not a pussy. I'm gonna deep throat clone it. Okay, so here's a libdil. Does it use CMake? Doesn't use CMake. Still improvement is there. Well, I mean, why am I creating build? So let's do configure. Let's configure the whole. What do you do when you don't have a configure script? Does anyone? I'm not familiar with the auto tools and shit. Like, so CMake, was there? Ah, there was a CMake. Oh, okay. So I'm an idiot. I don't know why I didn't see CMake. I'm sorry. So something is fishy. Why the download page gives you this thing that doesn't have or did it have CMake, or am I being stupid? I think I'm just being stupid as usual, right? So I think I'm just being stupid. I really apologize for that. So okay, so this is libdil. Let's do that, and let's just build the whole thing. Okay, not a single warning though. Look at that. The download out the classic. I think it's a signature of the author. Right, it's sort of like a signature of the author. Like all of the download links are fucking broken, right? So deal with that, right? So you know that that's the author of the libmeal and libdil library. So anyways, let's actually install this entire thing, right? So it's going to be in install, right? It installed it, and it feels like the interface is pretty much the same, like at least for our application that we are doing. Right, so because we're not doing select or anything like that. Yeah, it's a gatekeeper. Yeah, it's a gatekeeping strategy, right? So you have to prove that you're worthy to use this library. So at least for the simple application that we're using, the interface is pretty much the same, isn't it? Right. So here's the test, and I can probably literally just replace meal with deal. Boom, and then within echo, I replace meal with deal, and first. I replace meal with deal, right? And I compile all of them. Okay, almost. There's some differences in here, so there's no chan in there at least. Okay, so but this is for the first example. Let's actually omit the first example. Let's only build echo. Okay, so in echo there's no TCP sockets or anything like that, so they're probably called something different. What are they called? TCP. So, and what does it return? It, you have to, the difference is that it doesn't return it through return, it returns it through the argument. So, okay, I see. Like, I don't really want to do that, honestly. Right? It's like a kind of a mechanical refactor. Just change the style of calling all of these functions, you're gonna get the same thing, right? So, okay. I think it's nice to be aware of this library, but honestly, I kind of like the interface of Meal. Right, if I had to choose between these two interfaces, I kind of like the interface of Meal because of its simplicity. Right, maybe it's not going to scale well, right, because it's C. Maybe it's not going to scale well. And in C, there's a huge problem is that you can't be that careless as in Go with return values and stuff because you don't have a garbage collector, right? So usually C code converges into this really weird state where return values of functions are always used for errors, and any useful results are returned through the arguments anyway, by providing pointers and stuff like that, right? And because of that, C code usually not that convenient, right? And when you have this interface which actively uses return values, it kind of like feels nicer, but then it doesn't scale well. Then it just doesn't scale well because, again, it's a stinky C. It's a stinky half of a century old language that we're kind of stuck with. So yeah, I see. It's kind of cool, right? So it's just like a MILF library was sort of a challenge for the author to recreate the Go, right? And DILF is already, okay, so how would I actually do it in C if I didn't have these like creative limitations of recreating Go? I really appreciate that. This is literally the definition of recreational programming, right? So he didn't have to do that, right? So there is just Go, right? So just use Go. If you want to deliver the value to shareholders, just use Go and don't think about that. All of that shit is for nerds. But this author, right? So he's an artist, right? So just he's a philosopher, right? So what if? Let's try that. Okay, we created a cool library. But what if that? We created another cool library. That's what recreational programming is all about, and I highly respect that. Base library, 10 out of fucking 10. So this one also receives my star, both of them. Both of the libraries, absolutely fucking love them. Visionary, exactly. Eggs fucking Ackley. All right, so I think I'm gonna use it for something, right? I had a couple of ideas of for network applications, for simple network applications, and I was thinking to maybe use C3 with C3 foot for that. But since we have MILF, I might as well just try to use MILF for that. Okay, thank you whoever suggested. So yeah, I know who suggested that. Thank you so much, Sekenra the Sorcerer. I'm gonna give you VIP. Right, so because you suggested such a base library, right, there we go, you're VIP now. Okay, so let's take a look at the subs and resubs, recommitments. Thank you so much, Kaoimhaz. Thank you so much for Twitch Prime. Tim Artiro, thank you so much for this with the message, MILF is awake, deal with the right. Okay, Windump, thank you so much for Twitch Prime, and Coding Butter, thank you so much for tier 1 subscriptione. All right, so I guess it is time for me to go. We haven't raided anyone for quite some time already. Maybe the time has come to maybe raid somebody. So I forgot how to raid. Do we have any recreational programmers streaming right now? Anybody who's doing recreational POG ramming? John may be streaming? I don't see John streaming. Do you guys have any suggestions on who to raid? T2DE. T2... let me see, just a second. T2DE. I have no idea who that is, but we can try to raid them. So, yeah. Oh, T2DE. All right. So let's raid them. I wonder if it works through the chat arena. You started to raid. Do I have to now go to my dashboard and just confirm that. I feel like I have to go to the dashboard and confirm this entire scheisse because freaking Twitch, yes. So we have to wait until everyone has gathered, right? And we are ready now. There you go. Okay, that's it for today. Thank you all. I love you all. Mwah.